There are a variety of things that can cause pollution in a sewage network. First of all, blockages in a sewage network caused by fats, oils, greases, wet wipes, that sort of stuff. That can cause sewage to back up in the network and exit into people's homes or into the environment. Another area of sewage pollution are in combined sewer overflows, which effectively allow a water utility to discharge diluted sewage into a natural water resource during high periods of rainfall, where the downstream sewage treatment works has reached its full capacity. Problems in the infrastructure can cause those CSOs to spill too early, so that can be a source of pollution. And then another area of sewage pollution are rising sewer mains. So this is part of the wastewater network. It's characterised by having a pump at the bottom of a hill, pushing sewage up the pipeline to a high point. Now, they typically are the weakest part of a wastewater network, and they are prone to failure due to the higher pressures that pass through them. And so when they burst, they are typically located near local water resources, and so that can lead to pollution incidents as well.
Yes, it's possible to monitor leaks in sewage pipelines. This can be done by both internal and external methods, but due to the risk of environmental pollution from a leak incident, it's advised that an internal-based solution is installed. But when we talk about sewage pipelines, we need to take into consideration some difficulties. It is quite challenging to put instrumentation on the pipeline. Cellular needs to be considered in terms of how do we get the data out, and also a lot of the sections of pipeline are gravity fed, which makes leak detection more challenging. This is why at Atmos we have focused on a leak detection system for rising sewer mains.
Well, it's possible to detect leaks on a rising sewer main by utilising the negative pressure wave approach, which is fundamentally when a new leak forms, there is a drop in pressure, so a spike in negative pressure that travels in both directions along the pipeline. If we use instrumentation that can collect that pressure data quickly enough, so 60 times per second, we're able to see that drop in pressure and use that to identify and locate a new leak. Typically, this solution requires you to have pressure monitoring at 2 locations, and then you overlap the data, and that allows you to locate where the leak is between those 2 sensors. But in the case of a rising sewer main, you typically don't have an access point at the top of the rising sewer main, but what we are able to do is have an instrument at the bottom of the rising sewer main, and when a leak occurs in the rising sewer main, the negative pressure wave will hit the high point of the rising sewer main and then travel all the way back down. So we are able to use a single pressure monitoring device at the bottom of the rising sewer main that will capture both the negative pressure waves, and that can be used to identify and locate that new leak as it forms. Well, one of the key differences is actually a cultural one. So in the clean water environment, leakage is permissible. It's associated with moving water around the network under pressure. That said, it's been a regulatory requirement to reduce leakage since 1997, and so therefore the leak detection market is quite a mature one. But it does typically focus on using acoustic technology and focuses mainly on the downstream areas of a water network where you have high population areas. If we look at the wastewater network, there's typically leak detection isn't really a thing in a wastewater environment. There aren't any regulations that say you need to reduce leakage, but there are heavy fines associated with the pollution caused by wastewater leaks. And so what we're trying to do at Atmos is use our 30 years experience that we've accrued in the oil and gas sector, which focuses on finding new leaks as soon as they form, and bring that approach to the water sector, both on the clean water and on the wastewater side of things. So on the clean water areas, we will be able to perform leak detection further up in the catchment, further up in the networks, which will allow us to reduce leakage, but also reduce water supply interruptions to customers. On the wastewater side of things, the fact that we can utilise our negative pressure wave technique to find new leaks as soon as they form means that we can greatly mitigate the damage caused by by burst events in rising sewer mains, for example, which have a high proportion of burst rates. And that means we can also help water utilities avoid the associated fines with those pollution incidents.
Yes, we can utilise existing instrumentation for leak detection, but we need to consider a few things. We need to consider the repeatability, the resolution and the data acquisition rate of that instrument, and we also need to make sure that there's no dampening or pre-filtering applied to that instrument, as this can negatively impact the leak detection system. That's why at Atmos we prefer to utilise analogue pressure transmitters. In the oil and gas industry, we've gathered a lot of experience with pipelines with intermittent pump activity, but when we talk about a wastewater pipeline, what generally happens is half the section is pressurized and pumped, and then the remaining section is then gravity fed. We have a technology called Atmos Wave, which is based on the negative pressure wave principle, and this can be utilized on that pressurized section of the pipeline because this is the section of the pipeline that's most risk for new leaks and bursts. As well as this, the technology can distinguish the difference between pumping activity and new leaks and bursts forming. As we will know where the high point of the pipeline is from where the pipeline goes pressurized to gravity fed, what we can do is install equipment at one end and provide single-ended leak detection. But even with that single-ended leak detection, we can still provide a leak location to new leaks and bursts.
In a wastewater application, you need to find new leaks as they occur because the consequence to the environment can be high, and so the only real option available is a permanently monitored solution.
Yes, Atmos systems can be deployed on a range of pipeline materials. We can work with metal, plastic and other materials, and also we can work on a range of diameters along different pipeline routes.